All right, so we have we're kind of modifying things, and I hate to tell you this, so like if all of you are looking forward to conic sections, our chapter 12, and learning them inside and out, and you wanted to learn about the circles and the parabolas and the hyperbolas and the ellipses,
100%.
we're not going to get in as deep into it. That's kind of like the chapter that starts getting chopped when we have snow days and other days that are embedded in. I mean, life happens. It's not going to make you fail in math, and it's not going to stop you from pursuing your goals and dreams if we don't get as deep into conic sections as possible. They are kind of cool, but I'm kind of a math geek with it. I didn't like conics when I was in high school, so it kind of makes you normal if you're not going to like conics either. But we'll get as far as we can into it and figure it out. So today we're going to lecture on 11A, new unit. Tomorrow we're going to play the catch-up day. Okay, we still have the capstone. Some of you still have that. Some of you still have a quiz or quizzes, whether it's the most recent or something in the past. And then there's also review that can take place. I moved our third quiz to Wednesday. I know most of you are pretty upset about that. It was originally started on Monday, and then it was moved to Tuesday, and then it was moved to Wednesday. I hope we can stay on this path, but if we can't, we'll make it work. Uh-oh, someone's bringing in a green holiday card of some sort. It's looking good. Oh, thank you.
Yep.
Grant, what do you think you did? So if anyone ever comes and says, hey, you need an escort, man, there's an extra buck in it. If you just bolt out the door and run. Extra $1 if you go through the emergency door too, so you get $50. So what happened? I don't know. So sound like a plan for this week? We okay?
Yeah.
Can you lean on me if you need to?
Yep.
Yes.
Please do.
Do the chapter 9, please.
Do what? Yeah.
What is the last homework that we had to turn in?
Up to whatever the review had been.
So,
So I'm not taking in the review. I don't take reviews usually. So. So let's start out with this stuff. Rational functions. So I know that y'all are looking forward to this and are happy about this, but guess what? We have our third and final capstone on rational functions. So should we pre-test it right now, see how you do?
Yeah.
And whoever passes it doesn't have to take the test?
Yes.
Yeah, I'm in.
Yes. I'm down. I'm definitely
So-
do it.
No, thank you.
So rational functions just is this. It's reducing fractions. And it's reducing fractions a little bit more than just reducing two numbers. Okay, it's reducing where you're canceling out entire polynomials if you can. Can everyone reduce these fractions without any problems? Looks like 5 goes into 45 and 75, and 2 goes into 110 and 22, and let's see, 11? Oh, 11. Oh, thank you. Good eye. So 11, that would make it nice. 198, 126, I don't know. I know at least 2 works. I'm not sure what else. I'm not doing it in my head. But could you all reduce these fractions if you had this sit in front of you?
Yeah.
Hope so. Good. All right. So then we start looking at expressions saying, okay, how can we reduce an entire expression? So problem number 1, we have a denominator of 5. Agreed? And then I have a 15 and a 2a. So can that 5 go into both the 15 and the 2a?
No.
No, that's reduced. Okay. Problem number 2, you have a 3 as the denominator. Can 3 go into both the 6x and the 3?
Yes.
Yep. So that goes once, that goes twice, that goes once. So this comes up with an answer of 2x plus 1. Okay. Problem number 3. I have an x squared in the denominator. Ooh, start thinking your domain can't be equal to 0 on this one. But I have an x squared and a plus 3 on top. So being I don't have an x on the 3 at all, there's nothing I can reduce. So problem number 3 is reduced. And then problem number 4 can indeed be reduced because I have x squared, I have 5x, and I have x squared in the denominator. So I can reduce everything by a singleton x. So that'll become x to the first, that'll become x to the first, that'll cancel out. So I wind up with an answer of x plus 5 over x. and that's our reduced term. All seem legitimate so far? Okay. Can I move on?
Mm-hmm.
Waiting. Yep. Go. Hey, buddy.
Do you have any tissues?
No, just use your sleeve.
Oh gosh.
You probably would.
Sam, don't do it.
Don't.
I have a tissue.
Do it. I double dog dare you. You would carry tissues, right?
Can you not?
All right. A rational expression is in its simplified form, provided its numerator and denominator. Denominator. If I could spell, I'd be an English teacher. Have no common terms. Numerator top, denominator bottom. I don't know, your elementary teacher might have told you, remember denominator starts with D and D is down.
Okay.
Denominator. I'm sorry. There we go. Any other? All right. So that's the ins and outs of that. Let's move on. So if I can factor out a common term, so if I have AC over BC, you can reduce the C's, so you just wind up with A over B. And again, you can't have your denominator be 0, because that's kind of a bad thing.
But I thought 0 was the hero.
0 is a hero. To simplify a rational expression, factor the numerator and denominator, simplify any quotients that are 1, and leave the answer in factored form. Oh man, you're scaring me. Yeah, we're going to have quadratics that we get to factor out. We're going to have sum and difference of 2 squares and 2 cubes. Okay, so first one, I'd say 12 goes into 24 and 12 goes into 36. Anything bigger than 12 going to both?
No.
So 12 goes into, so I get 2 over. And then you go with the x's at the tug of war. Who wins, top or bottom on the x's?
Bottom.
Bottom by how many?
2.
And tug of war with the y's. Who wins, top or bottom?
Top.
By how many?
2.
Done. It's factored. It's reduced.
You've done this before.
Okay. Now we have 2 quadratics on top and bottom. And guys and girls, I will tell you the number one error that always takes place with these is students are like, ooh, x squared on top and bottom. Sweet, they cancel out. Nope. You got to break up the top. So the top factors to x plus 3 and x plus 4. And the bottom is x plus 3, x plus 5. And you take a look and say, okay, do I have anything on top and bottom that looks the same? And I would say x plus 3 is the same. So that and that cancel. So I get x plus 4 over x plus 5. And it's done. No, the x's won't cancel because it's part of a term. You have to take the whole term out. You can't just factor individually. So the name on number 1, you have a monomial over monomial. Number 2, you have a trinomial over trinomial. You factor the trinomials into binomials. Then you factor the binomials out. Does that seem okay so far?
Yeah.
Okay, and again, guys and girls, you won't make it right if you ever cancel out x squared. It's not ever going to be right. Cool, move on. All right, so on top I do have a binomial. So I have 5x to the third. So things that you have to remember on top, I can factor a 5x out of both, and that's going to give me x squared minus 9. What can you tell me about x squared minus 9?
X.
It's the difference of 2 squares, right? So then this is going to become 5x, x plus 3, x minus 3. I only took care of the numerator right now, right? So then on the bottom, it's like, oh, okay, I can factor out an x, and that leaves me x squared minus 7x plus 12. You can factor out the bottom. That x comes along. Looks like it's going to go to x minus 4 and x minus 3. Anyone want to take a shot at something that might cancel out top to bottom between the red and the blue?
X minus 3.
X minus 3, I'll do that. Anything else? Look at the very beginning of each.
Oh, I guess.
I have an X and an X. Those are gone. So I get 5, X plus 3 over X minus 4, and the problem's done. There's a term we're going to learn soon, but because I could factor out X minus 3 on top and bottom, it doesn't create an asymptote. It actually creates a hole in your problem. And a hole versus an asymptote. An asymptote like swoops up it or swoops down the asymptote. A hole means your graph starts, stops, starts again on the other side of the hole. And a lot of times on your graphing calculators, you can't see the hole until you zoom in like 10 billion times closer. And it's like the smallest microscopic thing. But if you went to the list, you would see an error, and that would have an error happening at x equals 3. It's not like the start of Hotel California.
What is that song about? Because I know it's about like a ghost hotel, but at the same time, like it could be about anything, honestly.
Hotel California?
Yeah.
It's about divorce.
No, I've always thought it's about drug use.
Divorce.
Either
Really?
that.
Yeah.
Starts with an S.
Weird.
No.
What's Stairway to Heaven?
I don't know. The Eagles, it was Don Henley was getting a divorce from his wife, and he wrote Hotel California.
Oh wow. I guess it makes more sense in drug use.
You can check out anytime you want, but you can never leave. So you can check out with the divorce, but you're always married to that person.
Oh yeah.
All right, problem number 4. Looking at the numerator, it looks like up here I could factor a 3 and an a out of both, and that leaves me a minus 4. Does that seem okay? And then the denominator, well, I don't know. Looks like I'm going to have a 2 and an A and an A. We're trying to do it factoring our quicker way. Anyone see what does it real quick? I would say this is probably a minus 3. Maybe. 6. Maybe. And then a... Nope, I'm off. I got to go back to my old school way. I got 2a squared, magic number of negative 24, 3 and 8, where that's negative. So 2a plus 3a minus 8a minus 12. You guys remember factoring by like this?
Yeah.
So that becomes 2a, or that becomes a 2 plus 3a, 2a plus 3 minus 4, 2a plus 3. So I get 2a plus 3 and a minus 4. Yay. So it looks like the a minus 4s are going to cancel each other out. And that'll leave me an answer of 3a over 2a plus 3. There's our answer. And because you have the exact same binomials cancel each other out on top and bottom, it creates something, when you graph it, called a hole. It's not an asymptote. And then we really get all demented with asymptotes. We're not only going to have vertical and horizontal, we're going to have one that's called a slant asymptote, which is also known in calculus as an end behavior asymptote. Yeah, we're sick. We good to move?
Yep.
All right, problem number 5 looks like x's will cancel out, so I'll get x plus 5 on top and x on bottom, and it's done.
Wait.
Wait.
Would it just be 5x or not?
No, because I had, so that'll become first to the first, and that cancels. So I'll cancel out an x out all 3 of those terms.
And you can't cancel out the x's
Nope.
at the end.
Because that's a binomial, that's a monomial.
Oh, okay. So if it has like a plus or a minus next to it.
Nope.
Wait, sir, what?
Sounds good.
On 5?
Yeah. Did you cross
Okay,
out?
so figure this. This is xx plus 5x
Yeah.
over xx. And then cancel a singleton x out of all 3 terms.
Nice.
Difference of 2 squares, yes? So y plus 9, y minus 9, right? And then on bottom, I can factor 2 out, and I get y minus 9. Being I have binomial on top and bottom, it creates a hole at 9. And then my answer becomes, and I know I keep saying that there's a hole, and they're like, what is this hole stuff? They're kind of cool.
It's a wormhole.
Oh, I haven't seen any worms come out of it. Number 7, I have x plus 3 on top. That's factored as is. On bottom, you can go x plus 3 and x plus 3. If you factor it out, if everything on top cancels out, you need to have a placeholder of 1. Some of you are saying, why did you cross out this x plus 3 and not that one? I don't know, because I ate red meat last night, I guess, so I could have canceled out that one. X squared plus 9.
X plus 3.
Nope. We don't have the sum of 2 squares, do I?
Oh.
So x squared plus 9 is factored as is. The bottom, I guess, would factor to be x plus 2 and x plus 3. Nothing to factor. So my overall answer, put it as factored form as you can. This actually has 2 vertical asymptotes, one at -2, one at -3. And it has a horizontal asymptote at 1. And it does not have an end behavior asymptote. And you're like, what are these terms that he's making up? Stuff I've never talked about before, but I'm just introducing it to you for later things in this chapter. Can I move on? Okay, how do we multiply fractions? Top to top, bottom to bottom. So you could also reduce it first. And I do recommend reducing your fractions first. So this would be 1/4. Some of you are like, no. It's 15 over 90. Nope, not 15. Yeah, is it 15 over 90? Did I do that right?
No.
2. Oh, that's a 3, isn't it? And that's a 6. Boy, you would think I could still do fractions as a teacher. So 15 over 90 is the same thing as 1 over 6. If I approach this second problem, I can reduce, being I'm multiplying everything together, I can say, you know what, 9 goes into 27, yay. 5 goes into 10 twice, yay. 8 gets canceled, becomes a 4, that becomes a 1. And then 4 does not go into 3, and 4 doesn't go into 25, so multiply what you have left. 4 times 1 times 1 is 4, and 25 times 3 times 1 is 75. Couldn't I just multiply all those numbers together on top and bottom and then reduce? Yeah. But then you deal with much bigger numbers, which sometimes reducing is better. How am I doing on time?
Not that much.
How many more I got?
6 more slides.
Holy shnikes. Okay.
But there's not that much on it, so.
Okay. The rule for multiplying expressions is the same, so A over B times C over D is A times C over B over D, and then simplify AC over BD if possible. You can also simplify before you multiply. That's just me talking. 5 slides left. Holy moly. Okay, it's multiplying 2 fractions, yes? All right, so let's take care of the numbers first. 5 goes into itself once, goes into 10 twice. Everyone okay with that?
Yeah.
2 goes into itself once, goes into 6 3 times. So I'm going to wind up with 3 over 2. How many x's does it appear I have on top? Remember, exponents are like bunnies. When they're next to each other and you're multiplying, they add, right? So how many exponents do I have on top that are x's?
5.
5. How many on bottom?
1.
Who wins tug of war, top or bottom? Top by how many?
4.
Okay. How many y's are on top and how many y's are on bottom?
3.
Y to the third on top, yes, and?
4.
4 on bottom, who wins?
Bottom.
By how many?
1.
1. And I can put y to the first, or I can just leave it like that.
Looks a lot harder than it is.
The silly trick that they throw you at number 10, I'm glad we're actually teaching it. We didn't just put it on there. One thing you have to recognize is I could factor out a negative on this, and I could change this to x minus 12. So take a look at that. If I distribute negative x, I get negative times x is negative x. Negative 12 is positive 12. Do you agree with that? So now, do I have something on top and bottom that's going to cancel? Well, the x minus 12, the x minus 12. And the 3, and the 3. So what's my answer?
-1.
-1, awesome. What's easy to lose on that one? The negative. Number 11 is kind of written out of term. So realize I could factor out a -4x. That's going to leave me x minus 1. Let me pause there. If I go -4x times x, do I get -4x squared? I think so. If I go -4x times -1, do I get a +4? Yeah, so I kind of factor it out and I change the order of it. Let's look at the denominator. That's going to factor to x plus 3, x minus 1. Is that okay so far? On top, that's going to factor to, is that x plus 3 and x minus 2? And then I have a 4x on bottom. Let's see what we can do to cancel some stuff.
X minus 1.
X minus 1's gone. Cool.
X plus 3.
X plus 3 gone. The 4x is gone. The 4x is gone. Don't forget the negative. So I get negative. The only thing I have up on top is x minus 2. You don't have to put the whole thing over 1. You can if you want. It's not necessarily incorrect if you don't.
So it's -x plus 2.
Negative times the quantity x minus 2, or if you wanted to go -x plus 2. I did it as the factored form, but you're not incorrect with the other. All right. Ooh. X plus 3 on top. Okay, that's going to stay as is for right now. So I think x plus 3 is fine. Oh, you guys aren't going to like me on this. This is the difference of 2 cubes.
Oh.
So that's going to give me 2x minus 1 times 4x squared plus 2x plus 1. That's what that whole thing factors to that. Yikes. And then I can multiply times this. That's going to give me 2x plus 1 and 2x plus 1. That's a perfect square trinomial. And even though we went, oh wait. This is over 1, yes?
Yep.
Can I take this, and can I take this, and can I cancel them? Are they the exact same?
Yeah.
That cancels that. Cool. That actually wouldn't have factored. Oh my gosh. This is a nosebleed kind of problem, I think. Hey, let me ask y'all something. Y'all know that you can get a copy of my notes on Schoology, right?
Yeah.
Was that the first time I've ever said that?
No.
So like you were aware of this? This is not some. This isn't some.
The first week of school.
This isn't some new bright idea where you're like, holy crap, I can get a copy of your notes.
No.
Okay. Do I record videos?
Yeah.
Yeah.
And I got a ranting parent said that I'm not providing enough support for their kid in my Algebra 1 class.
We're the only teachers.
And I'm like, a copy of my notes are here.
Poorly in that Algebra 1 class.
I don't know. Some people have been here.
It's like CP Algebra 1.
You sat in there and you're just like,
There's a junior in
you're
there.
like, square root of 2 is what? And they're like, square root of 2 is what? What two numbers multiply to give me 2? Am I talking to myself?
Wait. How do you do Algebra 1 in junior year?
That's a
You don't pass it your freshman and sophomore year.
It's hard. Oh my god.
Make that work.
It happens. It happens. I mean, I took Algebra 1 like 19 times, so.
Nice. She took it 3, I guess.
Yeah, there's different things. But you've been in there. It's like I'm almost going backwards. I'm regressing in math when I teach it sometimes. Sometimes when I'm teaching the concept, I'm thinking like, hey, I wonder if I should have some ice cream today after school. There is no math that's taking place in my head because
The one weird
It's always a great time to eat ice cream.
all right, dividing fractions. We got to multiply by the reciprocal, yes? So let's do the elementary school way. You agree with that? You cannot reduce originally when you're dividing them. So then you say, okay, well that's 3 times 3 is 9, 8 times 1 is 8. Okay, for the goodness gracious of all math, please realize it's okay to leave them as improper fractions.
Yeah, but my elementary school teacher said.
I know. Because they read out of a book because someone thought it was important who didn't understand math. Multiply by the reciprocal, flip that over, so I get 3 over 10. Now reduce one's multiply. Do what?
15 over 9.
Or 1 over 6. But 15 over 90 is the non-reduced form. I think this looking familiar?
Yeah.
Any more slides?
We got like 3 more.
Dude, it was like 3 more like 10 minutes ago. All right, so when we are dividing fractions, you have to make sure you multiply them by the denominator, the reciprocal of the denominator, and then simplify. Do not simplify in the beginning. You have to change it to a multiplication problem and start reducing. All right, so I'm just going to rewrite it with now it's multiplication, yes? I did the reciprocal of the right. Okay, let's see. 12 goes into 48 4 times. 12 goes in there 3 times. 5 won't cancel out, so now I'm going to get 20 over 3. And let's do some tug of wars. Tug of war with the x's. Who wins, top or bottom?
Top.
Top wins because I have x squared on top. Bottom has x, so tug of war top wins with the x's. No y's on top, so we're just combining, so I get y to the third on bottom. Problem 14, before we start reducing anything, let's change it into a multiplication problem first. Yes, I understand that x squared minus 1 will indeed factor. Did I get that? That's the difference of 2 squares on bottom. Do I have an x plus 1 on top? Yep. Do I have an x plus 1 on bottom?
Yeah.
So that and that cancel. I'm going to cancel one of those and then make that a first. That's all I have. So my answer is x to the first, or just x over 3 x minus 1. And again, if you leave it in factored form, you'll never get in trouble. If you want to convert it into where you distribute over, don't. It's just one more step.
Nice.
Seem okay so far?
Yeah.
Dividing fractions. Wow.
Last slide.
That's the last one. Giddy up. All right, let's convert it into a multiplication before any reducing takes place. I know some teachers be like, why didn't you combine 2 steps in one? Because I'm not that smart. Even though Dad calls me son doesn't mean I'm bright. All right, so now let's start breaking down our factors. So let's see, on this first one, it looks like it factored a 2x squared out of both. That leaves me x minus 6, agree? So that's what that is. Second one is going to break down to x minus 6, x plus 2. And if some of you are having problems with factoring, come see me. We can give you a little brush up on it. On top, should factor to 3 and 6, right?
Yeah.
X plus 3, x plus 6. And then bottom, it looks like I can factor out an 8x squared. That leaves me x plus 3. Okay, a few things are going to start reducing here. Let's see. X minus 6 on top and bottom. I like it. X plus 3 on top and bottom. 2 goes into 8 4 times. The x squareds cancel out. Beautiful. So then I get, looks like on top just x plus 6. And on bottom I get 4x plus 2. Good.
Nice.
That's as far as you can go.
That's extreme.
And of course, I went from a multiplication to a plus sign. That should be a multiplication sign. All right, last one. Ooh. So my magic number is negative 18. If you can't see it right away, I get 6x squared plus 9x minus 2x minus 3 over 6x squared times 1 over, let's factor that out. What does the top factor down to? I don't know. You guys are packing up and scaring me. Let's see, that's a 3x, 2x plus 3, negative 1, 2x plus 3. So that gives me 2x plus 3, 3x minus 1 over the 6x squared times 1 over x, 2x plus 3. 2x plus 3 cancels here and here. Nothing else to cancel, so I get 3x minus 1 on top, times 1 I guess you could say, over 6x to the third. All right, so we will do worksheet 11A. And I think some of you will like this. This will actually be due on Thursday. The reason it's due on Thursday is because tomorrow will be that review day. It'll be catch-up day. Wednesday we will do the quiz, final quiz of Chapter 9. And then we'll dive in a little deeper. Everyone good?